Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, today we will present about Module 2, Question 3. So, we are from Group 11. So, next I will introduce you guys to our group members, which is the first one is me, Ahmad Zafran Johari bin Muhammad Johari, 2025-428-974, and my members is Ellery Algar, 2023-114-165. So we proceed to our question 3. So based on question 3, it asks us to write and execute an assembly program that turn on LED 0 to LED R9 with three different conditions of switches as shown as the table in Q3, and the figure Q3 shows one of the LEDR patterns. So as you can see, that is the table of the table Q3 pattern of LEDR with three different conditions. The first one is press. The first one is on switch 1 is press. The not press, and the second one switch 2 is not press, while the switch 1 will press, and others. So this will make a different output of LED, either it will off and on. So as you can see on the figure question 3 also, the LEDR pattern is displayed when switch 1 is pressed. So this is simulated result. So before we go, I will introduce you guys to our objective, which is we got 4 objectives. The first one is to control LEDR output using switch input based on our coding. And the second one is to apply branching instruction for different switch conditions. The third one is to understand how memory mapped input and output is used in ARM assembly. And the last one is to observe the output pattern on LEDR 0 to LEDR 9. So for the flowchart, I will pass to my members, which is Ellery.
Okay, for this slide, I will explain the flowchart for question 3. The program starts by initializing the memory I/O address. The LDR address is set to the 0 times FF200000, while the switch address is set to 0 times FF200040. After that, the program reads the current switch value from the switch address. This process is repeated continuously so that the LED output can change whenever the switch condition change. So first decision, check whether the switch 1 is pressed and switch 5 is not pressed. If this condition is true, the program turn on the LEDR1, LEDR3, LEDR5, and LEDR7. The hexadecimal pattern is 0 times 0 AA is written to the LEDR address. If the first condition is false, the program checks the second condition. The second decision checks whether the switch 1 is not pressed and switch 5 is pressed. If this condition is true, the program turns on the LEDR0, LEDR2, LEDR6, and LEDR9. The hexadecimal pattern for that is 0 times 245 is written to the LEDR address. Okay. If the second condition is also false, the program checks the third condition. The third condition checks whether both switch 1 and switch 5 are pressed. If this condition is true, the program turns on the LEDR2, LEDR3, LEDR5, and LEDR6. So the hexadecimal pattern is 0 times 06C is written to the LEDR address. If none of these three conditions are true, the program enter the default state. In this state, all the LEDR output are turned off by writing 0 times 00 to the LEDR address. After each output is written to the LEDR, the program repeat the process by going back to read switch value again. This loop allows the LED pattern to update continuously based on the current condition of switch 1 and switch 5. Okay, this slide shows the ARM assembly code for question 3. First, the program starts with .global_start and _start. This tells the CPU letter where the program begins. Next, the program initializes the memory I/O address, and the register R0 store the LDER address, which is 0 times FF20000000, and register R1 store the switch address, which is 0 times 200040. After that, the program enter the loop section. In this section, the instruction LD R2 comma in bracket R1 reads the current switch value and store it in register R2. Then the program use the AND instruction to check switch 1 and switch 5. The instruction AND R3 R2 hashtag 0 times 02 check switch 1, which is bit 1. The instruction and R4 R2 hashtag 0 times 20 check switch 5, which is bit 5. For condition 1, the program checks whether the switch 1 is pressed and switch 5 is not pressed. If this condition is true, the program goes to condition 1. In condition 1, the value of 0 times 0 AA is loaded into the R5 and written to the LDER address. This turn on the LDER1, LDER3, LDER5, and LDER7. So for the condition 2, the program check whether the switch 1 is not pressed and switch 5 is pressed. If this condition is true, the program goes to the condition 2. In condition 2, the value is 0 times 245 is loaded to R5 and written to the LDR address. This turn on the LDR0, LDR2, LDR6, and LDR9. So for the condition 3, the program whether both switch 1 and switch 5 are pressed. If this condition is true, the program goes to condition 3. In condition 3, the value 0 times 06C is loaded to the R5 and written to the LDR address. This turn on the LDR2, LDR3, LDR5, and LDR6. If none of the conditions are true, the program enter the default section. In this section, the value 0 times 00 is written to the LDR address, so all LED are turned off. And at the end of each condition, the instruction B loop is used. This means the program repeat continuously and keep checking the switch condition. Hi, now I will demonstrate question 3 using step into. Okay, first we need to compile and load, and make sure the message show compile succeed, and make sure all switch are off first. Okay, this program use the switch as input and the LDAR as output. So the LDAR address is 0 times FF200000, while the switch address is 0 times FF200040. Okay, at the beginning, all the switch are off, and now I will step into to execute the program instruction by instruction. Okay, this instruction load the LDAR address into the register R1 and R0 and the switch address into the register R1. Okay, this instruction read the switch value from the address store in R1. Since all switch are off, the value in R2 is 0. And now we step into okay. Since no switch is pressed, the program enter the default condition. The value is 0 times 00 is sent to the LDAR address, so all LED are turned off. Okay, the first condition is switch 1 was on. So first we need to restart and click the switch 1. Okay. Next, I will test the condition 1 where the switch 1 is on, and make sure the switch 5 is off. Now we step into. Okay, this instruction read the switch value. For switch 1 only, the switch value is 0 times 02. So the R2 become 0 times 0000002. Next, we step into. Okay, the end instruction are used to check the switch bit. R3 is used to check switch 1, while the R4 is used to check the switch 5. For this condition, R3 become 0 times 02. So the R4 become 0 times 00. Okay, this program compare R3 with 0 times 0 too. Since the switch 1 is pressed, the condition is true. Then the R4 is compared with the 0 times 0, 0. Since switch 5 is not pressed, the program branched to the condition 1. Now we enter it, step into. Okay, in condition 1, the LED pattern 0 times 0, 0, AA is loaded into the R5. So the instruction strR5 comma in bracket R0 send this pattern to the LDER address. Therefore, the LDER1, LDER3, LDER5, and LDER7 are turned on. Okay, now is for condition 2. First we restart, and we need to turn off the switch 1 and turn on the switch 5. Now I will test the condition, this condition where the switch 1 is not pressed and switch 5 is pressed. So turn off the switch 1 and turn on the switch 5. Now we step into. Okay, for switch 5 only, the switch value is 0 times 2, 0. Okay, so the R2 become 0 times 0, 0, 0, 0, 0, 2, 0. So after the AND instruction, R3 becomes 0 times 0, 0 because switch 1 is not pressed, while the R4 become 0 times 0, 0, 0, 0, 0, 2, 0 because the switch 5 is pressed. Now we step into. Okay, the program checked the condition 2. So R3 is compared with the 0 times 0, 0, and R4 is compared with the 0 times 2, 0. So both conditions are true. So the program branched to the condition 2. Now we step into it. Okay, in condition 2, the LED pattern 0 times 245 is loaded into the R5. The instruction for strR5 comma in the bracket R0 send this pattern to the LDER address. So therefore the LDER0, LDER2, LDER6 and LDER9 are turned on. Okay, finally I will test for the condition 3. First, we need to restart. And for condition 3 is the switch 1 and switch 5 is on. So click it. Okay, now we step into. Okay, for switch 1 and switch 5 together, the switch value is 0 times 2, 2. And so the R2 become 0 times 0, 0, 0, 0, 0, 0, 2, 2. Now we step into. Okay, after the AND instruction, R3 becomes 0 times 0, 2. And showing that the switch 1 is pressed and the R4 become 0 times 2, 0, showing that the S5 is pressed. Now we step into. Okay, the program check condition 3, R3 is equal to 0 times 0, 2, and R4 is equal to 0 times 2, 0. So the program branches to the condition 3. So we step into. Okay. Okay. In condition 3, the LED pattern 0 times 06C is loaded into the R5. The instruction for the STR R5, in bracket R0 send this pattern to the LDER address. So therefore the LDER2, LDER3 and LDER5 and LDER6 are turned on. Okay. In the conclusion, this step into demonstration show how the program read the switch input, the address 0 times FF 20040. Checks the condition of switch 1 and switch 5 using AND, CMP and branch instruction, and sends the correct LED pattern to the LDER output address 0 times FF 0 times FF 200000. So all three conditions successfully produce the required LDER pattern based on the question table. Thank you.
Thank you, Ellery, for the explanation throughout our lab. So, for the conclusion, in this lab, we successfully designed, coded, and executed in an ARM assembly program using the CPU latest simulator to control hardware output based on specific input conditions, which is the three conditions that Ellery have been explained earlier. So the primary objective was to manipulate a sequence of 10 LEDs, which is the LED R0 until LED R9. So using the combination of two specific switches, which is switch 1 SW1 and switch 5 SW5 on a simulated DE1 SoC board. So I guess that's all from me. Thank you.